So consider we have these two matrices, A, which is 2, -3, 4, 1, and then B, which is -1, 5, 7, and 3. If you had to add these matrices, like for example, if you needed to find A plus B, well, all that means is you're going to add corresponding terms, right? So for instance, the first element here, which is in row 1, column 1, would be 2 plus -1, right? So that's 2 plus -1. And then row 1, column 2 would be -3 plus 5. And then row 2, column 1 would be 4 plus 7. And then row 2, column 2 would be 1 plus 3. Right? So the addition of matrices is pretty straightforward. It really is just adding corresponding elements. So this would give me, well, 2 plus -1 is 2 minus 1, which is 1. -3 plus 5 is the same as 5 take away 3, which is 2. 4 plus 7 is 11, and 1 plus 3 is 4. And that would be your matrix that represents A plus B. Something to recall as well is that only matrices of the same type can be added, meaning that this we call a matrix, well, we determine the order of a matrix by listing the rows times the columns. So for example, matrix A here has 2 rows and 2 columns, so it will be a 2 by 2 matrix. So A is a 2 by 2 matrix. And similarly, B is also a 2 by 2 matrix because it has 2 rows and 2 columns, right? And with matrix addition or even matrix subtraction, you can only add matrices of the same order, meaning that you could only add a 2 by 2 matrix to another 2 by 2 matrix. If I had like a third matrix and say this matrix C was 1, 3, right? That matrix. But this would be a 2 by 1 matrix because it has 2 rows, 1 row, 2 row, and then 1 column. I would not be able to add A and C or B and C because C is a 2 by 1 matrix, whereas A and B are 2 by 2 matrices. So you can only add matrices of the same order. Last week, we also looked at scalar multiplication, which is when you multiply a matrix by a scalar quantity. So for example, I could say 3a. The scalar here is 3, and 3a would mean 3 times a. And so I could say 3a minus 2b, for instance. Well, this would mean that I would have to multiply the whole matrix A, which is 2, -3, 4, 1, by 3, and then I take away 2 times the entire matrix B, which is -1, 5, 7, and 3. Now, when you are multiplying a matrix by a quantity, you simply multiply every term on the inside, every element in the matrix by that quantity. So for this, it'll be 3 times 2, which is 6, 3 times -3, which is -9, um, 3 times 4, 12, 3 times 1, 3. So this matrix, 6 minus 9, 12, 3 is the 3a, and then 2b, well, you'll multiply 2 by every element inside of the matrix B. So 2 times -1 is -2, 2 times 5 is 10, 2 times 7 is 14, and then 2 times 3 is 6. And now you can work that out by just subtracting. So if you have to subtract these two matrices, similarly, you're going to subtract the terms in the corresponding places, right? So the first one would be 6 take away -2. Well, 6 take away -2 would really turn to be 6 plus 2 because this minus and this minus will change to a plus. So 6 take away -2 would be 6 plus 2, which is 8. -9 take away 10 is -19. 12 take away 14 is -2. And then 3 take away 6 is -3. And this would be your answer for 3a minus 2b. And you could multiply a matrix by any quantity, meaning like it could be a fraction, it could be a decimal, it could be a negative number, any of the sort, right? And the criteria for multiplying a matrix by a scalar is just that, well, there's no real criteria. You could multiply a scalar by any matrix. It doesn't have to be any particular order. You could multiply a scalar by a 3 by 3 matrix, a 3 by 4 matrix, a 2 by 1 matrix. All that you're doing is multiplying every element inside of the matrix by that quantity, right? So for matrix addition, we can only add and also subtract. So matrix addition and subtraction, you can only add or subtract matrices of the same order. So again, that would mean that you could only add like a 2 by 2 matrix to another 2 by 2 matrix and that sort of thing, right? Now, today, we're going to look at matrix multiplication. And matrix multiplication is a little bit confusing. It can get confusing because it's just a lot that is happening, right? But before we even do an example of multiplying two matrices, you have to learn this rule, and this is the criteria for two matrices to be able to be multiplied by each other, right? So the number of rows, the number of columns, sorry. The number of columns in the first matrix must be equal to the number of rows in the second matrix. I want you all to write this down, by the way. This is very important. This is the only way to be able to multiply two matrices. The number of columns in the first matrix must be equal to the number of rows in the second matrix. And I'll show you exactly what I mean just now. I'm also going to send these notes for you, by the way. So if if I end up moving on and you wouldn't finish writing, don't worry, you can get it after. Right? So that means if you have a M by N matrix, right? If you have a M by N matrix, meaning that the first matrix has M number of rows and n number of columns, this can only be multiplied by a second matrix that has n times, like let's say P, where n and P, M, n, and P represent the number of, well, integers, right? So you realize this, n and n, they're the same, right? So in proper terms, or let me say in an actual example, like if I have a 2 by 3 matrix, right? This would mean the first matrix has 2 rows, right? And 3 columns. That can only be multiplied by any other matrix that has 3 rows. It could be 3 by 1, 3 by 2, 3 by 4. It doesn't even matter how many columns the second matrix has. All that matters is that that 3, right? It must have the same number of columns as the first matrix. So this matrix, the first matrix, if it's a 2 by 3 matrix, for instance, that means it has 3 columns. The second matrix has to have 3 rows, right? So it could be, like I said, any order except it must have three rows. So for instance, right, let's say I have a matrix, let's say I have a matrix 2, 3, 4, 5, right? And then another matrix 1, 5, 6, 7, right? These two matrices can be multiplied by each other because this matrix here, 2, 3, 4, 5, well, this is a 2 by 2 matrix, right? It has two rows and two columns. It can be multiplied by the second matrix because this second matrix also has two rows and two columns. So you see the two, right? This two rows, the number of columns in the first matrix is equal to the number of rows in the second matrix. The next thing is I could also have a 2 by 2 matrix, like say I had -1, 0, 0, 2, right? That's my first matrix. Well, again, this is a 2 by 2 matrix, right? It has two rows and two columns. I could multiply that by a matrix, let's say like this. Because the first matrix is a 2 by 2 matrix. It has two rows and two columns. And the second matrix here has two rows and one column. So this middle part, it has to be the same thing, right? Number of columns in the first matrix must be equal to number of rows in the second matrix. And this is a fundamental rule that has to be met in order for matrix multiplication to take place. And they do ask you questions like this. Like you may be asked, why can't you multiply matrix A by matrix B, for instance? I've seen that question in CSEC before. And when we start to do past paper questions, you'll see it. So this one rule you have to know. All right, you can only multiply two matrices if the number of rows in the second matrix is equal to the number of columns in the first matrix. And I like to write it out like this. So like I would write out the order of the two matrices to make sure that these two numbers in the middle are the same, right? So let's do a short little exercise. I'm gonna write out some matrices here and you'll tell me if they can be multiplied by each other or not, right? So let's say I had 1, 3, 5, 9 times 2, 4, 6, 8, 10, 12. Guys, can I multiply these two matrices?
Nanas.
You sure? What is the number of rows and columns in the first matrix?
It's 2 by 2 in the first matrix.
Right, it's a 2 by 2. And what about the second one?
2 by 3.
2 by 3. So I can actually multiply it. See? The number of columns in the first matrix is equal to the number of rows in the second matrix. Right?
Oh,
So you can actually multiply them. And that's why I like to write out the order like this. Like I would write out the order of the first one times the order of the second one to see if these two numbers are the same. And then I would know. So now if I were to flip this, right? Like if I instead wrote 2, 6, 10, 4, 8, 12. If I was trying to multiply that by 1, 3, 5, 9, what about these? Would this be able, can I multiply these two matrices? I mean, it's the same matrix. The same matrices basically, like let's say this is matrix A here and this is matrix B, right? So then you can do A times B, right? Because it's A is a 2 by 2 and B is a 2 by 3. But can I do B times A? Can I do that? Anybody? What are y'all thinking? What kind of
Nanas.
matrix?
No.
Yeah, correct. You cannot do it. Because what kind of matrix is B again? B is a 2 by 3, right? Because you have two rows and three columns. But A is a 2 by 2 matrix. And do you notice that these two numbers in the middle here, they're not the same, right? They're not the same. So you can do A times B. So you could find AB, but you cannot find BA because B is a 2 by 3 matrix and A is a 2 by 2 matrix. So this is something that's very important. With regular multiplication and addition, you expect that order does not matter. You expect that they'll be commutative, right? Meaning that, for example, 5 plus 3 is the same as 3 plus 5. And likewise, 5 times 3 is the same as 3 times 5, right? But with matrices, though matrix addition is commutative, meaning the order does not matter, A plus B is the same as B plus A, matrix multiplication is not commutative. Also something, guys, to make a note of, right? Matrix multiplication is not commutative. So the order actually does matter. And just because you could find A times B, right, does not necessarily mean that you can find B times A, right? So matrix multiplication is not commutative. That means AB is not equal to BA. So I would encourage you to, when you're trying to multiply two matrices, um, to write out the order of them, right? And the order is written by listing the number of rows times the number of columns. And I know that you all know it already, but I just want to show you again how we determine the order of a matrix. A is called a 2 by 2 matrix because you have 1, 2 rows. So that's 2 rows, row 1 and row 2. And then you have 2 columns, right? So the vertical, what can I call them? Arrangements would be your columns. So this is column 1 and this is column 2. So that's why I call matrix a 2 by 2 matrix where you have 2 rows times 2 columns. Now matrix B is a 2 by 3 matrix because you have 1, 2 rows, right? So that's row 1 and row 2. That's where I got this 2 from. And then it has 3 columns. 1, 2, 3. So that's where I got this 3 from. So that is how you identify or how you list the order of a matrix. All right. So now let's actually get into the strategy for multiplying matrices, right? So if I'm going to use letters first, right? If I have a matrix, let's say A, B, C, D, I'm using these letters as representation of actual numbers just to show you the strategy, right? And then I have another matrix, E, F, G, H, right? And I want to multiply them by each other. This is what I do. I take row 1 and multiply it by column 1 because this position that I'm trying to find here, this would be your row 1, column 1 position. This is your row 1, column 2 position. This is your row 2, column 1 position. And this is your row 2, column 2 position, right? Row 1, column 1 is literally, this is the first row, this is row 1, and this is column 1. So this position here is your row 1, column 1. This position next to row 1, column 1, well, it's in the same row, right? Because this is the same row, this is the same row here, this is row 1, right? So that's row 1, but however, it's in column 2. So that would be row 1, column 2 position. And then down here, well, this is your second row. So this would be row 2. This is your first column. So this position here is row 1, column 1. And likewise, this position here is the same row 2, but it's column 2, right? So it's important to be able to identify the positions. Anyway, to multiply this matrix A, B, C, D by E, F, G, H, what I will do is I will literally multiply the row 1 terms by column 1 terms. So the first term in row 1, column 1 would be A times E, right? So A times E plus B times G. So these are your row 1 terms, right? Right? These were your row 1, A and B, times column 1, E and G. So you get A times E plus B times G, right? Then your other term in the same row 1, column 2 now, that would be row 1, again, A and B multiplied by your column 2 terms in your second matrix. So it'll be A times F plus B times H. All right. And then on the bottom, this is row 2, column 1. So you're literally going to multiply row 2 by column 1. So it will be C, which is your row 1 term, by the first term in column 1, which is E. And then D, which is your second term in row 2, sorry, by G. And then likewise, row 2, column 2 would be literally row 2 times column 2. So it will be C times F plus D times H. And look at these similarities, right? In your row 1, you're multiplying A and B by your columns. In row 2, you're multiplying C and D by your columns. All right. So look, you could kind of look for patterns, right? Like these are the same because they're both from column 1, and these are the same because they're both from column 2. And you could see that for even the rows like A and B, C and C, D and D. Guys, math is about patterns. And the more you could identify patterns, the better you get. If you don't look at things like isolated events, look for patterns, right? So let's do a easy, well, not easy, but let's do an example with actual numbers, right? So we have, let's say I have 1, 3, 4, 7, all right? And I want to multiply that by 2, 5, 1, 3. So I'm looking first at my row 1, column 1 term. So that means I would literally multiply my row 1 by my column 1 terms. So inside here, the first thing, and I'm actually going to write out what I'm doing, it'll be row 1 times column 1, row 1. So that'll be 1 times 2 plus 3 times 1. That would be the first element in row 1, column 1. Now for row 1, column 2, that would be, again, row 1. So I'm looking at 1 times column 2 now. So 1 times 5 plus 3 times 3. Then I'm going to look at my row 2, column 1. So row 2 would be the 4 and 7, right? So it would be 4, and then column 1 is 2 and 1. So it will be 4 times 2 plus 7 times 1. And then I'm now going to look at my row 2, column 2. So my row 2, column 2 values are, this is row 2, 4 and 7, and this is column 2. So it will be 4 times 5 plus 7 times 3. And that's how I'm going to get all my values in my resultant matrix. So let's work it out and see what we get. All right, so 1 times 2 is 2 plus 3 times 1, which is 3. So I like to actually, I sometimes just write what it is down here. So like I'd have here, this is 1 times 2, which is 2, plus 3 times 1, which is 3. So 2 plus 3 is 5. And then here, 1 times 5 is 5, plus 3 times 3, which is 9. So 5 plus 9 is 14. 4 times 2 is 8. And then 7 times 1 is 7. So 8 plus 7 is 15. And then 4 times 5, which is 20, plus 7 times 3 is 21. 20 plus 21 is 41. And that is how you work it out. You could have actually written this out if you wanted it as another matrix, 2 plus 3 and then 5 plus 9. I just wrote it there. Now, with your matrices, guys, use 2 lines to write your matrix, okay? Don't write it tiny in one little line. Use your lines, use your space, space it out so that you could see things clearly. All right, let's do another one. Let's say I have matrix A is equal to 2, 3, -5, 4. All right. And then matrix B is equal to -5, 1, 0, 2. And say I want to find AB. Well, AB would be equal to 2, 3, -5, 4 by -5, 1, 0, 2. So this would give me, and I'm going to write out all of it, right? So this will give me, first I'll be looking at, this is row 1, column 1, right? I'm looking at the first element in this matrix. Also, these two matrices can be multiplied because it's a 2 by 2 by a 2 by 2. All right, let's go. So it'll be, so I'm looking at row 1 and column 1, right? So it will be 2 times -5 plus 3 times 0. That would be the first element, yes, first member there. Now I'm looking at, again, I'm looking at row 1, still, because I'm still in row 1, I'm looking for this position here. That's still row 1. So row 1, column 2 now. So it will be row 1, 2 times 1 plus 3 times 2, right? Now I'm going to go down. I'm going to now look at row 2, column 1, because that's the position I'm trying to fill. This position here is row 2, column 1. So I'll be looking at, let me just take off these circles here. Right. So I'm looking at -5 times -5 plus 4 times 0. Right? And now I'm still looking at row 2, but now I'm looking at row 2, column 2. So that would be, let me use a different color. Right. So I'm still looking at row 2, column 2. So it will be -5 times 1 plus 4 times 2. And that's how I would figure out each of the elements inside my matrix. Let's work it out now. So first I'm going to just work out the individual brackets before I go. So 2, you know what? Let's write it out. 2 times -5 is -10. So this will be -10 plus 3 times 0, which is 0. And then here, this is -5 times -5. A negative by a negative is a positive. So this will be 25 plus 4 times 0, which is 0. 2 times 1 is 2 plus 3 times 2, which is 6. -5 times 1 is -5. And 4 times 2 is 8. So now I'm going to add all of those for my final answer. So I will get -10 plus 0 is -10. 3 times 0, well, sorry, I would that out already. 2 times 1 is 2, and 2 plus 6 is 8. So here would be 8. Then I have 25 plus 0, which is just 25. And then -5 plus 8 is +3. And this would be my answer for AB. Now, if I had to find BA, it's not going to be equal to AB, right? Because remember, A times B is not the same as B times A. Matrix multiplication is not commutative. So on the next page now, um let's do B times A. So B was, let me write it. B times A, BA. B was negative 5, 1, 0, 2. And then A is 2, 3, negative 5, 4. All right. So multiplying, I will get, let's go. First, this will be row 1, column 1, right? To get this position, which is row 1, column 1. So it will be negative 5 times 2 plus 1 times negative 5. That's my row 1, column 1. Right? And now I'm going to look at still row 1, but column 2 now. So that would be using a different color. Still row 1, but now column 2. It'll be negative 5 times 3 plus 1 times 4. Right? And now we're going to look at this position here. Right? This position, which is row 2, column 1. So I literally go now with my row 2 and column 1 terms. So it'll be row 2 is this row, column 1 is this column. So it will be 0 times 2 plus 2 times negative 5. And then the last one, which is row 2, column 2, that would be, this is row 2 and this is column 2. So it will be 0 times 3 plus 2 times 4. Right, and now let's work them out. So this would be, writing it up here so you could see it. Negative 5 times 2 is negative 10 plus 1 times negative 5, which is negative 5. Negative 5 times 3 is negative 15 plus 1 times 4, which is 4. Then we have 0 times 2, which is 0, plus 2 times negative 5 is negative 10. And then we have 0 times 3, which is 0, plus 2 times 4, which is 8. So our final answer would be negative 10 plus negative 5, which is the same as saying negative 10 take away 5. That gives me negative 15. And then negative 15 plus 4 is negative 11. 0 plus negative 10, well, that's 0 take away 10, which is negative 10. And then 0 plus 8 is 8. So therefore, BA is equal to 15, negative 11, negative 10, 8. And we got AB on the previous page as negative 10, 8, 25, 3. So AB was negative 10, 8, 25, 3. So as you can see, BA is not equal to AB, right? They're not commutative. Right, so AB would be equal to 2, 3, negative 1, 0 times 1, 0, negative 2, 3, right? So the answer here, the first one would be your row 1, column 1, right? So that would be row 1 times column 1. So it will be 2 times 1, 2 times 1, plus 3 times negative 2. That's going to be your first value, right? Next will be your same row 1, except it's going to be by column 2 in this case, right? So row 1 times column 2, that's going to be a value that's going here. So it will be 2 times 0, 2 times 0, plus 3 times 3. Now for the other one, we have row 2, column 1. So this is row 2 by column 1 we're looking at now. So it'll be negative 1 times 1 plus 0 times negative 2. All right. And then finally, we're going to be looking at the same row 2, but now column 2 as well. So row 2, column 2. So it's going to be negative 1 times 0 plus 0 times 3. Right? And now you just work out each of those individual ones. So 2 times 1 is 2, right? So that'll be 2 plus 3 times negative 2, which is negative 6. And then here you have 2 times 0, so that's 0, plus 3 times 3, which is 9. This is negative 1 times 1, so this will be negative 1, plus 0 times negative 2 is 0. And then 1 times 0, which is 0, and 0 times 3, which is also 0. So the full answer now, let's write it out by working out these. 2 plus negative 6 means 2 take away 6. That would give you negative 4. 0 plus 9 is 9. Negative 1 plus 0 is negative 1. And then 0 plus 0 is 0. So your answer for AB would be negative 4, 9, negative 1, 0. Guys, I'm noticing a trend, right? And the trend is this. Those of you who like don't write the things out properly seem to be making mistakes, and that happens, right? I would recommend writing it out exactly as I've written it here so that everything is outlined clearly. And as you get more comfortable with the topic, then you could start to like just go from like this A, B to the answer. But you see this second step here, I would recommend doing it because it helps to outline all the steps that you need to take. Matrix multiplication is a tricky topic. So please write it out exactly as I have it because I do believe that it will help you to really understand the steps properly. My experience is that students who try to skip the step in the middle here when we're now learning it tend to lose the whole concept altogether and get themselves confused, right? So please write it out exactly as I have it. Not because I want you to follow my method or anything, but just because I think at this point it will help you. All right? Don't skip steps. So that is this one is AB. Now let's look at BA. I'm gonna go to the other page just so that I can have a little more space, right? So BA would be B times A. BA. B was 1, 0, negative 2, 3. And then A was 2, 3, negative 1, 0. Right. So again, and I'm going through it step by step with you. Your first position is row 1, column 1, right? So that means I need to look at row 1 and column 1. Row 1 from the first matrix, column 1 from the second matrix. So this would be 1 times 2 plus 0 times negative 1. That's the first element there in your row 1, column 1. Now we're going to move on to row 1, column 2. So still row 1. So it's still 1 and 0, but now it's going to be column 2, 3 and 0. So this would be 1 times 3 plus 0 times 0. All right. Now let's look at the row 2, column 1 position. So row 2, column 1, this is row 2, and this is column 1. So row 2 times column 1 would be negative 2 times 3. Oops, sorry, I made a mistake. Sorry. Column 1 is here. Sorry. So row negative 2 times 2 plus 3 times negative 1. And then finally, you have still row 2, but you're going to be looking at column 2. So that's this row, that's row 2, column 2. So this would be negative 2 times 3 plus 3 times 0. Right? And now let's work out each of those individual ones. Like I said, you could actually write it out if you want. You could write it out like this if you don't want to, like you know how before I was just writing it on top here, like on top here. You don't have to do that. If you want to even make it clearer, you could write them out. So I'll say 1 times 2 is 2 plus 0 times negative 1, which is 0. Then 1 times 3 is 3 plus 0 times 0, which is 0. Negative 2 times negative 2 times 2 is negative 4 plus 3 times negative 1, which is negative 3. And then finally, negative 2 times 3 is negative 6 plus 3 times 0, which is 0, right? These numbers came from up here, guys, right? 1 times 2 is 2 plus 0 times negative 1. 1 times 3 is 3 plus 0 times 0. Negative 2 times 2 is negative 4 plus 3 times negative 1, which is negative 3. Negative 2 times 3 is negative 6 plus 3 times 0, which is 0. I just wrote it out here as well, just for clarity, right? And now you work them out. So 2 plus 0 is 2. 3 plus 0 is 3. Negative 4 plus negative 3 would be negative 7. And negative 6 plus 0 is negative 6. And that is your answer. I can't guarantee anything, but I think that you would be able to follow through if you write it out, right? And guys, again, use 2 lines, right? So if I had lines, these blue would be my lines. These blue lines are the lines in my notebook. You see how I write in it? The matrix in 2 lines. I don't want to write the matrix in 1 line like this. It's gonna be too small and confusing. Use your space in your notebooks. Okay. Right. So let us take a little break, right? It's 5:34. Let's take 10 minutes. So let's be back here at 5:45. Yeah, let's say we have a matrix A, which is um, 2, -3, 4, 5, right? And say we are required to find A squared, right? Finding A squared, guys, does not mean that we just square each term inside of the matrix. So it doesn't mean that it'll be 2 squared minus 3 squared, 4 squared, 5 squared. That's not what A squared means. A squared, as you know, means A times A, right? So A squared, in terms of matrices, you would have to multiply the entire matrix A by itself. So A squared would actually be 2, -3, 4, 5 times 2, -3, 4, 5. That's what A squared will be. You have to actually multiply the entire matrix by itself, not just square each term inside there. All right, so let's go. This would be, well, row 1, column 1. So it will be 2 times 2 plus -3 times 4. right? Sorry, I didn't do the circling, and I think that kind of helps. And then row 1, column 2. So row 1, column 2, that would be 2 times -3 plus -3 times 5, right? And then finally, well, not finally, we still have two more to go. It'll be row 2, column 1. So row 2, column 1, that's this position here. So that would be 4 times 2 plus 5 times 4. And then the last one, row 2, column 2. So row 2, column 2, this is row 2, this is column 2. So it'll be 4 times -3 plus 5 times 5. All right, and let's simplify this. So this would be, well, 2 times 2 is 4. -3 times 4 is -12. 2 times -3 is -6. -3 times 5 is -15. 4 times 2 is 8. 5 times 4 is 20. 4 times -3 is -12. And then 5 times 5 is 25. All right, so that would be, I'm going to write it out as well. So you'll have 4 minus 12, because plus minus is minus. -6 minus 15. 8 plus 20. And then -12 plus 25, right? I just wrote it there just for clarity. And then finally, the answer would be, well, 4 plus -12 is -8. -6 take away 15 is -21. 8 plus 20 is 28. And -12 plus 25 is 13. So a squared is equal to -8, -21, 28, 13, right? So if you are ever asked to find a matrix, the square of a matrix, you have to literally multiply the entire matrix by itself, not just squaring the elements inside, right? Good. So guys, I want to look at um, just some examples, right? I'm just going to give you all some examples for the rest of class, right? So I'm going to write them on the screen, and then, yeah, I want you to try them. So, oh, by the way, I didn't show you all this, but the identity matrix, right? The identity matrix, what is known as the identity matrix, is for like a 2 by 2 matrix, right? So the identity 2 by 2 matrix, I should say, right? This is important for when we're gonna do the inverse of a matrix. So the identity 2 by 2 matrix is given as 1, 0, 0, 1. And if you multiply any matrix by that, the identity matrix, you get the same matrix, right? So it's just like in the regular number system, the identity is 1. And if you multiply any number by 1, well, you get itself, right? You get that number. Similarly, in matrices, you have identity matrices, and when you multiply a matrix by the identity matrix, you get the original matrix, right? So for example, let's say I had a matrix A, and this matrix is 4, 3, 5, 2, right? And I want to find AI, right? So finding the identity matrix times, well, finding A times the identity matrix. Well, that would be AI would be 4, 3, 5, 2 times 1, 0, 0, 1. All right, and look what this will give us. Well, row 1, column 1, row 1, column 1 would be 4 times 1 plus 3 times 0. And then row 1, column 2 would give me, so this is column 2 and it still is row 1, so that would be 4 times 0 plus 3 times 1. And then on the bottom now, we're going to be looking at row 2. So this is row 2 times column 1. So this would be 5 times 1 plus 2 times 0. And then finally, the last one, which is still row 1, but now, still row 2, but now column 2 as well. It'll be 5 times 0 plus 2 times 1. All right, and then simplifying all of that, we'll get, well, 4 times 1 is 4, plus 3 times 0, which is 0. 5 times 1 is 5, plus 2 times 0, which is 0. 4 times 0 is 0, plus 3 times 1, which is 3. 5 times 0 is 0, plus 2 times 1, which is 2. And then just writing all of that out, well, that would be 4 plus 0, which is 4. 0 plus 3, 3. 5 plus 0, 5. And then 0 plus 2, 2. So as you can see, it's the same matrix, right? So therefore, AI is actually equal to A. So any matrix multiplied by the identity matrix is itself. Right. So at this point, guys, I'm gonna write down some and I want you all to try them for me. Good. So AB would be equal to 3, 2, negative 1, 4 times negative 4, 1, 3, 0. That would give me, well, 3 by negative 4 plus 2 by 3, row 1 times column 1. And then row 1 times column 2. So that's 3 times 1 plus 2 times 0. And then row 1, column 2, row 2, column 1, sorry. So that's negative 1 times negative 4 plus 4 times 3. And then same row 2, so negative 1 times column 2, so that's 1 plus 4 times 0. So that will give me, let's see, 3 times negative 4 is negative 12 plus 6, then 4 plus 12, 3 plus 0, and negative 1 plus 0. So then I'll get negative 12 plus 6 is negative 6. 3 plus 0 is 3. 4 plus 12 is 16, and negative 1 plus 0 is negative 1. So AB is equal to negative 6, 3, 16, negative 1. And then the second part of the question, we had to find A, B, C. Now, because matrix multiplication is associative, ABC can be found by multiplying AB by C. And we already got what AB is um, in this first part of the question. So I'll just write that, which is -6, 3, 16, -1 times C, which is 5, -2, 7, 6. So this would give me, I'm going to use the finer pencil now. So that'll be -6 times 3, because it's row 1, not 3, sorry, 5. Row 1 times column 1, so -6 times 5 plus 3 times 7. Same row 1, but now column 2. So this will be -6 times 5, no, times -2, because that's column 2, plus 3 times 6. And then on the bottom, I have row 2, but column 1. So this will be 16 times 5 plus -1 times 7. And then same row 2, so -16, not -16, sorry, just 16. 16 times row 2, column 2 now, which is -2, plus -1 times 6. All right, so that would give me, and let's simplify those. Use a different color. -6 times 5 is -30. 3 times 7 is 21. 16 times 5, what is 16 times 5? 16 times 5 is 80. So this is 80 plus -7. 1 times 7 is -7. And then -6 times -2 is +12 plus 3 times 6, which is 18. 16 times -2 is -30. -1 times +6 is -6. So I end up now with the final answer is put it in blue. So A, B, C would be equal to -30 plus 21, which is -9. 12 plus 18 is 30. 80 plus -7 will be 80 take away 7, which is 73. And then -30 take away 6 is -30 take away 6 is -36. There we go. Just want to make this a little better. I hope you all are getting through with them so far. Let me know if you didn't. Oh, wait, I made a mistake here. Oops, I didn't see this. This should have been 32. -32 take away 6, which will be -38. Sorry about that, guys. 16, let me see. 16 times 2 is 32, yeah. So -16 times -2 will be -32. And then the last one was you were supposed to find, what were you supposed to find? C squared. And C squared means C times itself, right? So C squared literally means 5 by 5 -2 7 6 times 5 -2 7 6. So this would be equal to, let's go, row 1 times column 1 would be 5 times 5 times 5 plus -2 times 7. Then same row 1, but now column 2. So that would be 5 times -2 plus -2 times 6. Now we're on to row 2, column 1. So that would be 7 times 7 plus 6 times 6. Oops, I made a mistake. See, it's really easy to make mistakes there, so you have to be careful. Row 2 times column 1, so 7 times 5 plus 6 times 7. And then, oh gosh, it has 6, 7 in this. Gross. And then row 2, so that's 7 times -2. Row 2 times column 2, so 7 times -2 plus 6 times 6. So when I'm doing it, by the way, I'm looking for certain things to match. For instance, I'm looking to see that this is the same, right? Above and below. I'm looking for those to match. So if I don't see that matching, that's how I know I make a mistake, right? And also the other things that are matching would be in the rows, the first numbers. So 5 and 5, -2 and -2, 7, 7, 6, 6, right? So those are like some of the indicators that I use while I'm doing the question to make sure that I'm doing the correct thing. Right, so simplifying now, we'll have, well, 5 times 5 is 25. -2 times 7 is -14. 5 times 2 is -10. Plus 2 times 6, which is 12. Oh, that's negative, so that's -12. 7 times 5 is 35. 6 times 7 is 42. 7 times -2 is -14. 6 times 6 is 36. Right, so now I just work out all of those. And I'm using my calculator, by the way. I didn't use my calculator for 16 times -2, and I see I got it wrong. All right, so 25 take away 14 is 11. -10 take away 12 is -22. 35 plus 42, 2 plus 5 is 7, 4 plus 77. And then 36 take away 14, 22. So this is your answer for C squared. Guys, as you see, this you could easily make a mistake, right? So don't beat yourself up. I make mistakes too with it. It's something that takes a lot of practice. And even with a lot of practice, it's a lot of numbers. So you could get confused, right? All right, the next one is I'm gonna do that one and that would be it for today, right? But I want to make sure and do it so that if you were doing it, you could, check and see. And even if you didn't get so far, afterwards you could, watch the recording again, pause it and work it out and then look at the solution. So I have P is 4, 3, 2, 1. And then Q is -1, 0, 0, -3. The first thing I had to find was PQ. So let's find PQ. PQ would be 4, 3, 2, 1 by -1, 0, 0, -3. So let's go. It's row by column, row by column, row 1 by column 1. So that's 4 times -1 plus 3 times 0. That's your first value, your row 1, column 1. Now for your row 1, column 2, same row. So it's still going to be 4 times something plus 3 times something, right? It's the column 2 values that would go in here. So that's 0 and -3. All right. And now for your bottom, well, the row here is row 2. So it'll be 2 times your column 1 and then 1 times your column 2, your column 1 as well. So your row 1, row 2, sorry, is 2 and 1, right? 2 and 1. So that's where this 2 and this 1 came from. And then your column 1 is -1 and 0. And make sure it's matching on top, right? Because it's the same column. So these numbers will be the same. And then on the bottom, you have same row 2. So it's still going to be 2 times plus 1 times, right? But now it's a column 2 values, which is 0 and -3. It matches with the one on top. See? Right, so that would be, let's simplify. So 4 times -1 is -4. 3 times 0 is 0. 2 times -1 is -2. 1 times 0 is 0. So 4, -4 plus 0, -2 plus 0. 4 times 0 is 0 plus 3 times -3 is -9. 2 times 0 is 0. 1 times -3 is -3. So all of that now would be our final answer. I'm writing it here just because I want more space, right? So PQ would be equal to -4 because 4 plus 0 is -4. 0 plus -9 means 0 take away 9. So that'll be -4, -9. -2 plus 0 is -2. And then 0 plus -3 is -3. So -4, -9, -2, -3. The next thing you had to find was, what did you have to find next? QP. And as we know, PQ is not the same as QP. QP would be equal to -1, 0, 0, -3 times 4, 3, 2, 1. This is equal to, well, your first row 1, column 1, your row 1 values are -1 and 0. So it'll be -1 times 4 plus 0 times 2. Row 1 by column 1. Next, the next value here, next element, is still row 1. So it's still going to be -1 and 0. But this time you're multiplying by your column 2 values, 3 and 1. So it'll be 3 and 1. And then now we're looking at your row 2 values by your column 1. So it will be 0, that's your row 2 value. This number has to be the same as the one on top here because that's your column 2 value. So 0 times 4 plus -3, that's your next value in your row 2, times next value in your row 1, which is the same one as up here. Right? Same row 2, so it's still going to be 0 times and -3 times. And then it's going to be a column 2 values, which are 3 and 1. Right? So our answer is, oh wait, before we move on to the answer, let's work these out. So this is -4 plus 0, -3 plus 0. Oops, I forgot to write plus between these, and I need to write those because if you just put brackets, it literally means multiplication. So I need to put the brackets. Good. 0 times 4 is 0 plus -6, 0 plus -3. Good. And now let's work these out. So this would be -4 plus 0 is -4. -3 plus 0 is -3. 0 plus -6 is -6. 0 plus -3 is -3. There we go. The next one was, if anybody has to leave, please go ahead. I'm just going to finish the questions. C, which is P squared. P squared will be P multiplied by itself. So that would be 4, 3, 2, 1 times 4, 3, 2, 1. Let's go row 1 by column 1. So 4 times 4 plus 3 times 2. Same row, so it will still be 4 times and 3 times, but now we're looking at column 2. So that's 3 and 1. Again, I forgot to write a plus. Good. And then on the bottom, it's column 2, sorry, row 2 now. So that'll be 2 times column 1, which would be the same value from on top here. That's 4 plus 1 times 2. Same row 2. So it's still going to be 2 times plus 1 times. But now we're using our column 2 values, which are 3 and 1. So 2 times 3, notice, same thing here, and then 1. Let's work it out. 4 times 4 is 16. So 16 plus 3 twos are 6. 4 threes are 12 plus 3 times 1 is 3. 2 fours are 8 plus 1 times 2. 2 threes are 6 plus 1 times 1. Excellent. So this would be 16 plus 6, which is 22. 12 plus 3 is 15. 2 plus 8 is 10. 6 plus 1 is 7. All right. Part D. Part D, we needed to find Q squared. So that's Q multiplied by itself, which would be -1, 0, 0, -3 by -1, 0, 0, -3. Let's see. Row 1 times column 1. So -1 times 0 plus, I made a mistake. That's -1 times -1. Row 1, column 1. So row 1 is -1 times -1 plus 0 times 0. Row 1 times column 1. Now, same row 1, which is -1 times, and then plus same row 1, so it's 0 times whatever is in column 2. Column 2 are 0 and -3. The column 2 values are 0 and -3. And then on the bottom, this is row 2 now, so we're looking at 0 and -3. So it'll be row 1, so it's 0 times -1, it matches this one, and -3 times 0. Same row 2, so it's 0 times something plus -3 times whatever's in column 2. Column 2 is 0 and -3. And you see they're matching, right? I'm doing it like this just so that I can highlight the matching nature of it. All right, so let's simplify now. -1 times -1 is +1. 0 times 0 is 0. -1 times 0 is 0. 0 times -3 is 0. 0 times -1 is 0. 3 times -3 times 0 is 0. 0 times 0 is 0. -3 times -3 is +9. So my final answer here would be 1 plus 0, 0 plus 0, 0 plus 0, 0 plus 9. 1, 0, 0, 9. Now we need to find 3 times PQ. Now I already have PQ over here. So 3 times PQ, I would just need to multiply 3 by every element inside PQ there. So PQ is um, PQ is -4, -9, -2, -3. Let me double check. Yes. So then, therefore, 3 times PQ would be 3 times PQ would be equal to 3 times -4, -9, -2, and -3. And that would give me, you have to multiply 3 by every element inside it. So the answer would be, well, 3 times -4 is -12. 3 times -9 is -27. 3 times -2 is -6. And 3 times -3 is -9. So that's the answer. And then the other one was 2/5 by PQ. So 2/5 by PQ would be the same principle. You have to multiply 2/5 by every element inside PQ. So 2/5 by -4, -9, -2, and -3. Now you could leave this as improper fractions if you wish, right? So this would be 2/5 times -4. So that'll be -8/5. You're just going to be multiplying numerators, right? -9 times 2/5 will be -18/5. -2 times 2/5 will be -4/5. And then -3 times 2/5 will be -6/5. Now, if you did it like this is fine. If you wrote it as mixed numbers, that would also be the correct. It would also be acceptable. So -8/5 will be -1 3/5. -18/5 will be -3 3/5. -4/5 will just be -4/5. And then -6/5 will be -1 1/5, right? And if you work it as decimals, so this should be all. I should write all here, right? So it doesn't matter, guys, if you leave it as improper fractions or if you do it as decimals. So this will be -1.6, -3.6, -0.8, and then -1.2. Any of these would be acceptable for this answer, whether you leave it as improper fractions, mixed numbers, or decimals.